All right, we are live streaming, except for X. For some reason, X
That's
is
fine.
not working today.
I'm not an X.
No, it's not a great place. All right, here we go. So we're live streaming. I have Maxim Segeren of Tree Composites joining me on the podcast. This is day one at Jack World 2026. And thank you, my friend, for spending some time. I'm glad we finally worked it out and we could get you on the podcast today.
Yeah, thank you for having me.
Yeah, absolutely. So before we begin, let's start with yourself. A little bit about your background in the industry. So before we get into Tree Composites, let's talk about you.
I'm a curious person by nature, but
okay, I like that. I like that.
So my background really lies in the design of structures.
Okay.
So I did my let's say my studies in offshore engineering.
Okay.
Where I focused on structures for actually renewable power.
Okay.
And graduated on these type of structures, so jacket lattice type of structures.
Absolutely. Yeah.
And I already noticed that fatigue is like a huge issue. So cyclic loading and how welds behave on it. And then I was already fascinated about that. But then first did my PhD on connection steel to steel.
Okay.
Also for offshore wind turbines. And after that, I really wanted to make a change in what we do. So I bridge actually the gap between academia and industry. So only seeing, hey, we have really bright ideas.
Yeah.
How do you get them actually to be used?
Okay.
Especially in offshore wind is quite challenging, but I really had, I think, a good go in let's say for 6-7 years we built up many projects with the industry, really looking at how we can do things better. Mm-hmm. And one of the projects that I came across, or at least an invention from the University of Delft, was a way to connect steel tubulars.
Okay.
And my first impression was, I broke my pencil in the past, and then tried to fix it with let's say some tape.
Right. We've all done that. Right?
Yeah, exactly. So, and it was not the best connection. So, so I was very skeptical.
Yeah.
And then, so the inventor's name is Marko Pavlovic.
Okay.
He said, "Now come and have a look." And he showed me, let's say, test results actually that the steel started to break outside of the composite.
Okay.
Well, what does that actually mean is that the composite outlives the material lifetime of steel in terms of, so really...
Sure. Which is the whole goal, right? I mean, it's you want to, for composites, you want to long life, but not in this case where you're...
But if you know the difficulties of welding, you suddenly realize, but the whole structure is dominated due to the welds. It is really how you have to have the welds is always dictating how thick things will be.
Right.
And I thought, wow, no, really? And I was very enthusiastic, but the first thing I did is, are people actually interested in it? So I started to have a round with the industry partners, like the big players like Vattenfall, Shell, and saying, hey, are you really interested in this? And how do you see this being used? Can we have already a steel manufacturer supply you this? And they said, nah. And that steel supplier also said no.
Yeah.
And then we went to the composite world and saying, could you make this? Right. And I was like, no, we do composites, right? So and it was okay. So we have a great idea. We have a So then I said, well, I know both worlds. Why don't I give it a go? And then I, of course, first with these partners, can you then also support from day one? What do you want to in return? And then we actually established the company in 2020.
Wow.
And now we're almost 5.5 years ahead, and I think we're progressing really well.
It sounds like it. So I thought you guys won the Innovation Award last year.
Yeah.
And but was it for the TC joint? No, it was. Yeah. Oh, okay, it was. Okay. So I thought like that was for something different, but this is the TC joint that we're talking about.
Exactly. So we, for those who don't know us, because so you replace traditional welding by placing composite on a larger surface.
Right.
And if you do that, you omit all the difficulties. So it's every green place in this structure. And that means that you can connect steel tubulars without welding.
Okay.
And we can do that in two ways. One is that we actually produce the the joint itself and then ship it to any yard,
Okay.
or we go to the site and then you only have full tubular lengths.
Okay.
You line them up and we infuse the joint on site.
On site. Okay.
So and that saves a huge amount of labor.
Okay.
And this is also where you see these structures, if they're welded, they use 10,000 hours of welding.
Sure.
And then if you look at, okay, if we need to produce 50 of those per, for example, offshore wind farm, then it's a huge amount of labor needed.
Sure.
And then if you want to produce it locally in, let's say, Western Europe, then you are having troubles to be cost competitive to low wage.
Yes.
And that's where then you get to the real value, as in, okay, how can we still make our structures in, let's say, high wage countries if we use lots of labor?
Right.
And you see the pressure on offshore wind. You have seen that also in the US, but also in Europe. Project developers are looking ways to reduce the costs, and if you cannot reduce costs locally, then you look abroad.
Absolutely.
But then you create this dependency, which you cannot get out of.
So what we're looking, is this an offshore wind? Is this the bottom, or what are we looking at? Okay.
Yeah, so this is the foundation. Actually, the majority of the structure you don't see because it's underwater.
Yeah.
Exactly. But it supports a tower or any type of structure.
And these underwater welders, I got to say, they don't come cheap, right? I mean, it's very expensive.
No. But we recently, it's not on the website yet, but we recently signed also a contract with Tenet. I don't know if you know this, but these are the TSO. So they build like structures like 8 times bigger than a foundation for a wind farm.
Yeah.
And they use like 10,000 tons of steel. And also they look at, okay, hey, how can we reduce the amount of material that we use? Okay. Because if you use composite in a structure, you more or less reduce the amount of steel with, let's say, 40 to 60%.
Right.
Just because the weld is so dominating the amount of steel that you have to put inside. So if you then look at the bigger structures as well, then you save a huge amount of steel. That is already better for CO2, of course.
Absolutely.
But also you actually accelerate the total construction time. And then if you want to have these high targets, let's say in Europe, we have 300 gigawatts that we want to realize in the next 25 years. And let's say of those 300, we still have to install 270 gigawatts. So the first 25 years, we install 30. And now the next 25, we're going to accelerate. But then you need to have a faster way of actually constructing.
Yeah. I mean,
sorry, lots of information.
No. I'm thinking, my brain is going while you're talking. I'm like, I mean, what are some other, outside of this, we're talking offshore wind. What are some other areas or industries that you would love to be involved with these TC joints? Yeah,
so indeed, when we started the company, we looked at, okay, where is the real value to be gained, right? Yeah. And we saw, okay, offshore wind, especially these lattice type of structures,
okay,
they have the biggest penalty for, let's say, welding, but also they have the biggest challenge in to become cost effective and fast out. So we saw, okay, the impact here is the biggest, but we looked at 28 markets, and they are all big because lattice structures are used really everywhere. Right. But also the first adopter needs to have a reason to change, right? And we see indeed, okay, offshore structures are heavily loaded, heavily driven by fatigue, and there also we see that, okay, fabrication times are dominated by the amount of welding inside. So we see, okay, this is really our let's say, biggest impact market, but it's also a big market and a very conservative market. Right. So we're also looking at other application fields. So, for example, in 2023, we built a floating structure, fully composite, by the way, for offshore solar.
Okay.
But we could also use it in bridges to even.
I was going to ask on like infrastructure type out. Stuff.
So. Anything that you connect with tubulars, and it doesn't matter whether it's steel or whether it's aluminium, because the reason why we don't have a lot of composite structures is because we didn't have a way to connect composite tubulars, right? In a, let's say, and to be able to predict it as well.
So you said, backing up, you said they're conservative. What do you mean by, are they slow to adopt? Okay.
And that's because of if you look at introducing something new in offshore wind, you have to imagine that, okay, this structure let's say, is between 40 and 80 meters high.
Yeah.
And only that structure, let's say, costs around 15 million.
Right.
But then you put a turbine on top, you have a foundation piles as well. So total will be like 50 million per structure. And then it's already challenging to do that right now.
Right.
And then I say, hey, I have something new. Do you have a track record? Oh, no, yeah. Not yet, right? But we have 8
We'd
years.
like you to be the first, right? I mean,
Yeah, no, but
Yeah, no.
but that industry is actually nobody wants to be the first. They would like to be the second.
Yeah.
And that's also where you need see. Okay, on this side of the world, we are lacking. Let's say actually the part to actually pay the risk or the finance the risk part of innovations. So every client wants to pay for the product itself.
yeah.
But then, okay, what if something like a risk occurs? That is hard to finance.
Right.
So we are working, let's say, with the Dutch government, but I also think in Europe we are looking at, okay, how can we actually accelerate actually adoption of innovation which have bigger impact or high financial risk? Because if, for example, well, of course, we have to reassure that it will be staying operational for 20 or 35 years.
Right.
So it cannot be, you trust me in my blue eyes, right? So I don't have blue eyes, by the way, but that's a saying in Dutch.
Yeah. Yeah.
And that's also the reason why we did now, I think, 8 years of data collection on all the uncertainties that people see, all the risks. And that's just necessary to introduce something new in a, let's say, an entire structure in a fast manner. And I remember that we had a discussion with industry partners and saying, yeah, but it works, right? And that was 2020. And he said, why do you need another 5 years? He said, well, because nobody's going to buy it if you cannot assure that it will work always.
Yeah.
So lots of fatigue tests, full scale tests,
Right.
all the uncertainties that you have with.
On a fatigue testing, is it through a way to extend? I know that's you can, accelerate or project the longevity in that up to a certain point, right? Or a length of time.
Yeah, so you have in Belgium, you have a dedicated test center, only looking at the impact of fatigue improvements on wells.
Okay.
And they say, okay, every percentage of fatigue lifetime really is a cost reduction. So we did our test, and they knew that it would be better, but it was, let's say, over 10 times longer lifetime. And these are, let's say, normally they are in like few percentages.
Okay.
So suddenly we're talking about 10 times more. So they were like, whoa.
Yeah.
Right? As in, if this is really it, then okay, it solves all those problems.
Right.
And there's still, and I think one of the things that unlocks is that we're talking about circular economies, but this entire structure suddenly can stay out there for 2 or 3 project lifetimes.
Yeah.
So what does that mean is that, okay, we place one time a structure, it costs, let's say, 1 billion per wind farm, and then after 35 years, you can keep it out there.
Wow.
It's better for ecology,
Yeah.
but then also we don't know what happens in 35 years. We don't know what the steel price will be. We do know that decommissioning costs are significant, so you save on that. The only thing that you do is like replace whatever is on top of it. And then, that's for a long term, but that is really long term, and we don't see that really materializing in let's say, projects right now.
Okay.
But your asset that you build with it has a higher, let's say, value at the end of its life.
Yeah. So where can you have a booth located here, and I meant to add that onto our show, but mention real quick where they can find you. Are you at Hall 6 or Hall 5?
Hall 5, B117.
B117, Hall 5. If you're happen to be streaming by Hall 5, B117.
Yeah, so if you have ways to help us to get to, let's say, just a wind farm alone, I didn't say it, but we're talking about 5,000 tons of composites.
Okay.
That's where we want to go to.
Wow.
So if you can help us, drop by.
Absolutely. Mention your podcast too, by the way.
So we also have a podcast called Future in Steel. and that really explains a little bit more. Okay, background, but also the inventor is in one of the episodes, but also the test center also explains a little bit what it means for them.
Is that where people can find out on? First of all, we forgot to play this. Can we play this?
Yes, you can play. Hopefully it doesn't.
Hopefully it plays.
Yeah.
There we go. Let's see if it's streaming.
Yeah.
Let's make it a little bigger. Oh, look at that.
Yeah. So we're really indeed connected without any welds.
Wow.
Yeah. So this is the smallest full scale you will see. So this 3.5 meters high. But we're talking about really the biggest structures in the world that we can really reduce the amount of steel necessary to build them. This is the floater that we built.
Oh, okay.
So this is full composite. So all the tubular members are composite. This is really the first, let's say, of its kind. And I think that is really something that we also are talking with some parties here at YAC. Okay, can we also accelerate full composite structures in civil?
Sure.
Because it doesn't corrode, it's lightweight, so it has many benefits. So yeah.
And that is treecomposites.com. Maxime, thanks for coming by.
Thanks
for
having
visiting.
me.
Glad we could connect and do this podcast. So look forward to catching up with you. And will you guys be at any other major shows that you'll be at the remainder of the year?
Yeah, we will be visiting in Madrid, the Wind Europe fair. So you can also see us there.
All right.
Thank you.
I'd love to make a trip to Madrid. All right. Take care.
Okay.